This lecture is in two parts. This part provides an introduction to concepts regarding exposure and the exposome, and the second part discusses exposure in more detail. There are several learning objectives for Part 1 and Part 2 of this lecture. These include defining the concept of exposure and the elements which constitute exposure and the exposome, being able to describe the relationship between exposure and health effect and how this is determined in studies, being able to identify the parameters needed to assess exposure, and understanding how to assess exposure quantitatively using a simple model. What do you think of as your environment? Do you think of the street you live on, the building you live in, the car or bus you take to school or work? All these are part of our environment. The impact of the environment on health is far-reaching. Your environment also includes the foods you eat, the water you drink, and the kind of soap or spray cleaner you might use. We know that all these things have the potential to influence your health. A concept has emerged in recent years called the exposome. This concept brings together the idea of our environment as a set of interconnected systems which impact our health. The exposome is composed of every exposure to which an individual is subjected from conception to death. Based on that definition, we can infer that to characterize the exposome, we must look longitudinally over time. The exposome is also an interdisciplinary concept. In the original conceptualization of the exposome, the environment is basically all aspects outside and inside the body that is not the human genome. The external exposome refers to the environment outside the body. The external exposome is further characterized into two other spheres: the general, which tends to include contextual information, such as whether you are in an urban or rural area, the climate where you live and work, or measures of socioeconomic position. The specific external sphere includes exposure to risks such as pollution, but also factors such as diet and smoking. Finally, the exposome also accounts for a person's internal body environment, which includes the various molecules and microbes that exist inside us. The exposome is about the interaction of these three spheres. In these lectures, I will focus mostly on the specific external sphere, but it is important to note that this is not independent of the other two spheres of the exposome. Let's define what we mean by exposure. Exposure is defined as how an individual or population comes into contact with an agent, including quantification of the amount of this contact across space and time. The term agent, in the context of exposure, refers to a chemical, biological, or physical entity. Examples of chemical agents include lead and formaldehyde. Examples of biological agents include bacteria and viruses. Examples of physical agents include heat and noise. Exposure is essentially at the interface of the environment and the internal physiology of the human. However, to have a deeper understanding of these relationships and to help us develop more effective policies to protect public health, it is useful to look at factors which influence how we get exposed to environmental factors and the likelihood they will impact different people. In this diagram, we can see that different attributes of a person influence their environment and behavior, thus influencing their exposure. Other attributes affect how susceptible they are to the risk of adverse health effects from these exposures. If we think very technically about exposure, it really is where we come into contact with agents at the tissues that compose the border between the outside and the inside of the body. Typically, this means the skin surface, the lining of the lungs, and the lining of the gastrointestinal tract. Exposure implies the potential for the agent to cross over through the epithelial layer of cells into the body circulation and therefore affect other cells. For an environmental agent to have a health effect, exposure to the agent must precede the health outcome in question. In environmental epidemiology, we would ideally try to assess a quantitative exposure-response relationship, meaning how much variation in exposure leads to variation in health outcome. To do this, we need to reconstruct in a retrospective study or measure in a prospective study where, when, and how long exposure occurred. Health effects may be acute or short-term, where health impacts occur immediately or within a short time period after exposure. Short generally refers to no more than a few days post-exposure, referred to as a lag period. Chronic health effects occur after long periods of exposure, for example, after years of exposure. This exposure is usually either continuous or occurs regularly over a long time period. Now, we will talk about some examples of short-term exposure and health effects, as well as long-term exposure and health effects. First, we start with short-term exposure. Air pollution has been known to affect health for decades. This analysis examines a famous pollution event in December 1952 in London. Here, you can see a clear relationship between increases in air pollution levels in terms of sulfur dioxide and smoke, which today would be similar to particulate matter. Air pollution levels rise sharply after the 3rd of December, peaking around the 7th, and then decrease sharply to baseline levels after the 9th. Deaths also sharply rise and peak around the same period as the pollution. Deaths remain higher than the levels prior to the pollution episode for several days afterwards. Today, air pollution levels are not quite so high, but time series studies, which is a study designed for looking at short-term impacts of air pollution, still show effects on mortality, hospital admissions, and other acute effects. The figure here is from an analysis across 26 cities in China that shows increased risks of hospital visits per 10 microgram per meter cubed increase in particulate matter of various sizes. The effect is strongest within the first 2 days of exposure. Now let's talk about long-term exposure. Cancer is a health effect which is considered chronic. It occurs after either an accumulated long-term exposure and may not always manifest until years after exposure stops. This example is looking at occupational exposure to asbestos in a cohort of textile workers. The exposure accounts for the idea that there needs to be a longer duration of exposure, reflected by only including workers with a minimum exposure of 1 month, and looking at a measure of their cumulative exposure over time. Also, we expect that the effect would not occur until sometime after the exposure begins. Therefore, there was a minimum latency period prior to assessment of the outcomes, which were deaths from asbestos-related diseases, including lung cancer. The results show a clear relationship between the amount of exposure, which is a cumulative measure of asbestos fibers over time, and the standardized immortality ratio, which shows that a much greater number of deaths were observed than would be expected in a non-exposed population. Another example of chronic exposure is for lung cancer and arsenic. The setting here is 2 cities in a region of Chile which share a water supply. The unique characteristic of this situation is that there was a discrete period of time during which the water supply was much higher in arsenic than normal because of supplementation from a river with high arsenic levels. The levels of arsenic returned to lower levels after a treatment plan was installed. 2 cohorts were studied, those born during the time when the water supply had high arsenic concentrations, which means that they can look at exposures to children while in the womb, and those born just before this time, when arsenic levels were lower. Those born earlier in 1950 to 1957 would not have been highly exposed while in the womb, but would have been highly exposed as children. This graph illustrates the levels of arsenic in the drinking water of this area of Chile, and you can see that the arsenic levels during the exposure period of interest was clearly many times higher than other periods. The results of the analysis show that lung cancer was clearly higher for both males and females in the region compared to non-exposed people, for those born prior to the high exposure time, and for those born during the high exposure time. This indicates that very high arsenic exposure in drinking water leads to higher risks of lung cancer, especially when exposure occurs in utero or during childhood. This ends part 1 of this lecture. Thank you for listening, and please go on to part 2.